Okay, so we are starting here, and I do have my conversion chart. I think it's somewhere in the back right there. So in the last lesson, we ended dimension analysis. Dimension analysis is about it's a problem-solving method that we use in chemistry, very popular in chemistry. Dimensions here, analysis talks about units. So we're using the units of the value. So remember, in tend to measure a lot of different measurements, and the measurements have specific units. Dimension analysis is a way of solving problems to convert from one unit to another, but the method you're using is driven by the starting unit, the given unit, and then the wanted unit. So we are starting here today. Let me see how I can navigate through this. I have my PowerPoint here. I need my conversion chart. I think it's right there. Oh, there it is. Okay, so in this first conversion problem, we are converting from yards to centimeters. So I hope that I can be heard. You're converting from yards to centimeters. So yards is a length unit, and so is centimeters. If you're trying to make this kind of conversion, you want to actually go to your conversion chart. So I do have mine right here. I downloaded it earlier, and then anyway, it's here right now. You want to see if you can find a direct conversion between yards and centimeters. So you see how this conversion chart is categorized by types of measurements. So we have a length category, we have a mass category, we have a volume category. And I'm going through the lengths right now because these are both lengths, right? I go through here and I'm looking for either centimeters or yards. So I go through and I see centimeters, but the centimeters here is not written with yards. Oh, I got centimeters here too. Once again, not with yards. So I keep going on. These are both metric prefixes, so I keep moving on, go down here. Do I see, oh, I see a yard here, but the yard goes with meters, not centimeters. So I keep going just to make sure. I go through here. Do I see yards again? Yes, yards with mile, yards with inches, yards with foot. So I do have how many yards to pick from. I can pick from this yard right here, this, and this. Let me go with the first, okay? So I'm going to write my conversion equality. All the measurements written here are written in equality form. That means the same object or the same distance, in this case in the length, was measured, but it was measured in two different units. So 1 yard is the same as 0.914 meters. I'm going to write that right here. 1 yard equals 0.914 meters. Now I found a yard to meter equality. I did not find a yard to centimeter equality. So the yard to meter only takes me so far. I want to go to centimeters. So imagine this was a kind of like a game where you're progressing from one end to another. We've made it from yards to meters. Now we have to go from meters to centimeters. So I can go back here. I think I saw a meter and centimeter right there. 1 meter is 100 centimeters. So I'm going to write this right here. 1 meter is equal to 100 centimeters. So I think I got all the conversions I need for this problem. Okay, I'm going to set this right here so I can easily go back and forth. There. I got my conversions. Okay, this is working on the next page, but I'm going to work it right here. So you start with the given. This is essentially your problem here saying convert 1.76 yards to centimeters. So I'm going to write the given. Well, they wrote it for me. 1.76 yards. So 1.76 yards. Okay. Then I draw my conversion brackets. I'm actually realizing I may need a little bit more space. Let me try to move this a little bit to the left there. Make it slightly smaller. Okay. Now, the way these conversion brackets work or dimension analysis works is that the units you have here, oops, I like the bright yellow one. The units you have here must diagonally match the units you write on the bottom. Oops, wrong thing. On the bottom right. So the units must match from top left to bottom right. They must be the same unit. So that drives what you pick next. Since my units right here is yards, I have to pick a conversion factor that has the word yard in it or the units yard. I look up here, I have two to pick from. Only one has the units yards to pick from, right? So I'm going to use that. I will write the number and the word yard on the bottom. So this would be 1 yard. And on top, I'll write 0.914 meters. Now remember, these equalities, they're like a combo. They go together. So once you use the yard on the bottom, you must use this one here, this 0.914 meters on top. You can't use any other one. You can't crisscross. So I'm done using that. The yard and the yard will cancel out. Now the unit that drives my next movement is the dominant unit, meters. I have to pick a conversion factor that has meters in it. So when I look over here, oh, look at that. That's my next one. So my next one, I will write 1 meter down here and then 100 centimeters up here. It just so happens, oh, I didn't write my wanted. My wanted is right here. They wrote it for me. I'm being lazy. They wrote it for me. It's right here. So since I can tell where to stop by my wanted, once I get my wanted or desired unit in the right position, I can stop. I don't have to keep going on because I'm done with setting up the problem. So this is it. As far as the math is concerned, I'll do 1.76 times 0.914 times 100, and my answer will be in centimeters, right? That's the only unit that remains. Okay, where's my calculator? Right here, yes, I'm going to use a calculator. 1.76 times 0.914 times 100. Okay, so I have this huge number, 160.864. Well, how do I round it up? I have to go back to the question. The question gave me a number that was 3 significant figures. So my answer has to only have 3 significant figures. So I count from left what positions are going to remain. Okay? This position remains, this position remains, this position remains. Everything else has to be canceled off. Since the first number after the valid position is an 8, you round up and we end up with 161 centimeters. That's my answer in 3 significant figures. Okay? Does anybody have any questions about that method? Remember, you use your given number to determine the significant figures of your wanted. Okay? Okay. So they gave us a plan here. They use their own conversion. I mean, you can use whatever conversion you want. I could have used any one of the 4 that was provided or the ones that I saw. I picked the first one. Okay. Okay. Next problem here. We're doing a unit conversion involving units raised to a power. Okay. Here it says, calculate the displacement, the total volume of the cylinders through which the pistons move of a 5.7, so we're given 5.70 liters, automobile engine in cubic inches. Okay, so what I'm going to do here is, I know what they were trying to do. They were trying to get us to use cubic inches conversion, but since the conversion chart I've actually done this before, I've taught this class before, has a liter to cubic inches conversion. I'll give you guys another question while we're here. But for right now, let me continue with this, okay? Let's see. Do we actually? Yeah, let me see what we find with the table. So we have 5.70, so we have a 5.70 liters, and they want us to go to cubic inches. So let me actually see before I make conclusions, right? Or assumptions. If we do have, they want us to go all the way to inches cubed. I will click on, oh, my mouse is so far from me. Let me scoot things a little over, rearrange things so it's a little easier. Click down here. Okay, liters is a volume and so is inches cubed. Any kind of length cubed is a volume. So on the side here, I'll write length cubed is a volume. Okay, so let me go over here and look at the volume category and find my conversion. So I may have misspoke too soon. I did say that we had a conversion lengths and inches, right? Let me see. Sorry, inches, right? Let me see. We have a liter here. I have a liter and meters cubed. I and centimeter cubed and decimeter cubed. I have a liter, centiliter, milliliter. I have a bunch of liters here. I'm not seeing one with inches cubed. Let me keep going and see. There's liters here, and then, okay. I am not seeing one with liters. But what I'm going to do here to try to keep it simple is I am actually, do y'all see the one here with liters and feet cubed, right? So I want to use that. Because before I went along with the way they wanted us to do stuff, and then I had people call me out and say, "Well, why don't you use that one?" If it was me, I'd use that one. So I was like, "Okay, I'll do the ones that you want me to do." Okay. So I'm gonna pick this one based on what my students told me before. I will pick 1 foot cube equal 28.37 liters. So this one here. Then my next one is, since I'm going from liters to foot cube, I have to pick a conversion that has foot cube. Look, to the right, I have 1 foot cube equal inches cube. So I have 1 foot cube equal 1728 inches cube. Okay? Remember, I have this sheet downloaded, this table, well, uploaded, actually not downloaded, but it's uploaded on eCampus. So feel free, I really encourage you to download it, print it, and keep it for your records. Okay, back to our conversion. I'm drawing my table. I think I have all the conversions I need. If not, I can feel free to come to this table right here and grab what I need. So let me do this. Okay, back to this table here. Now, since I have liters here, liters drives my next action. I have to use a conversion factor that has liters in it, right? That will be this one. Oops, I keep using the wrong utensil. That's okay. That's that one. So 28.37 liters will be on the bottom. On the top, I'll have 1 foot cubed. And over here, I have 1 foot cubed, right? I put that on the bottom. I used this already. And on top, I write 1728 inches cubed. Liters cancel out. Foot cube cancels out. My answer is in inches cubed. I didn't have a direct conversion, but I had a conversion that made it possible for me to not cube units. But I'll do one that requires you to cube units, okay? So I have here 5.7 times 1728. I'm doing the numerator. I'm multiplying that out, divided by 28.37. I forgot to write it out. I got distracted by the email. Okay, I'm doing 5.70 times 1728 divided by 2837. That's how I'm entering the numbers in my calculator. And of course, inches cubed, right? So I end up with 347.18, and it goes on. So I go back here and I look at the numbers. I was given only one number. That one number has three significant figures. So in my final answer, this number remains, this number remains, this number remains, then everything has to be rounded off. The first number after the 7 is 0.1. So the 0.1 is less than 5. I can drop everything off. My answer will be 347 inch cubed. Okay, so let me give you a problem that's realistic that allows us to cube units. Okay, so here, once again, my answer is 347. I'll give you guys a moment to write this down while I take a sip. Yeah, I'm having a tea while I'm doing this. Okay, so there we have our answer. Does anybody have any questions? Once again, if you have questions, feel free to write in the message box, and that way, you know, I can address them as I'm going along. Don't wait till the end to ask a question. Ask me during the lesson. That way I can address it in context. It makes it a little bit easier. Okay. So yeah, they pick their conversions. Let's see. Our answers are slightly different based on the conversions we picked, and they actually went ahead and cubed units. So what I want to do here, before I move on to density, because we're almost done with chapter E, can you imagine that? We're almost done. I want us to work on a problem that's a little bit more realistic. So I'm going to make up a problem right here, and I'll call this just convert 1.742. What do I do? Let me go with inches cubed to centimeter cubed. Okay, since I'm making up this question here, the purpose of this question is for you to know how to cube units. When you look at this once again, this is an inch cubed to a centimeter cubed. Essentially, both of these are following the format of length cubed. That means we're going to be looking at the volume section, right? To see, do we have a volume conversion that goes directly from inch cubed to centimeter cubed? If not, so look at volume first. I apologize. My neighbor decided to use this time to do a remodel. Okay, I have no idea, but it sounds like it's right on top of me. So look at volume first, and then if you don't find anything in volume, then look at length. Okay. So we have two places to look at our conversion. So let me go ahead and lift this up slightly. There's the other chart. There. I'm going to look at volume. Can I find an inch cube or centimeter cube? There's a centimeter cube. Is there an inch cube nearby? Nope. Centimeter cube here, here. Looking some more, looking some more. I do find an inch cube, but it's nowhere near centimeter cube. So I'm not seeing the conversion I want. I mean, you probably could ask, well, why not just go with inch cube and feet cube? I could use that. But when I go from inch cube to feet cube, then I go from feet cube to what? Liters? And where do I go from here? I guess I could go from liters to centimeter cube, right? Anyway, what I'm trying to do right now, y'all, is I'm trying to show you how to cube units. So I'm not going to use that method. When you're working on this on your own, feel free to use whatever method you want. I'm just trying to show you the skill, okay? So I am going to move over to the length section. In the length section, there's no cubes here because it's a basic length, right? The basic units. I can and maybe 8 meters and inches. Oh, right here. 1 inch equal 2.54 centimeters. Okay, that's what I want. Okay, so I'm going to move over here. 1 inch equal 2.54 centimeters. I for my conversion, and the goal here is to show how. Since my starting unit is inch cubed and I only have 1 inch, what you want to do is convert equality to desired units. So I really wanted to have inch cube to centimeter cube, so I'm going to do that. And how will I do that here? I will cube both sides. So I'm going to write 1 inch. I'm going to cube the number and cube the unit. 1 cubed, let me space this out a little bit so it's not so confusing. 1 cubed inch cubed. This is equal to 2.54. You have to cube both the number and the unit. 2.54 cubed centimeter cubed. Okay, cube both. Okay, so 1 cubed is 1. 1 power anything is still 1. Then this becomes inch cubed. So for the number 2.54, find cube in your calculator. If you cannot find it, use hat 3. Okay, I get 16.387 centimeter cubed. So now I have the conversion I need, right? I can use the conversion as I need it. So I'll start. This is finally the desired conversion, the desired unit. I start with my given number, the one I made at 1.742 inches cubed, and then you have 1 inch cubed on the bottom, right? These have to match, and this is 16.387 centimeter cubed, and we are done. Okay, so my answer is now in centimeter cubed. I have my number 1.742. I multiply this out. So I have 1, 2, 3, 4. 4 significant figures in my answer. My number, my answer will be 4 significant figures. So I write 28.55. Okay. Once again, the point of this lesson was to show you how to cube units. Okay. The thing with chemistry is math is a means to an end. So we're trying to use math to be able to process the chemistry, right? To make sense of the chemistry and to prove theories and stuff like that. So we cube units and stuff, and sometimes it makes math majors who are in this class uncomfortable, but we do that because it serves our purposes. Okay? We're not really violating the numbers per se. We're keeping the numbers and the units consistent. Okay? Any questions about the units? Since y'all are not really asking a whole lot of questions because I think you're all really that quiet, if you have, say, 4.71, just making up a number, and you have meters squared, and you're asked to get kilometers squared, once again, since you have squared, you want to find the conversions between meters and kilometers, and then just go ahead and square those. Okay, so square conversion factors. So we are converting the conversion factor to get the conversion factor we want, to use it as a conversion factor to get the unit we want, right? Some deep stuff. So yeah, you square the conversion factor. Once you square it, I guess it'd be 1 kilometer is equal to 1,000 meters. Square this, square the 1,000, square the meter, and then use that. Oh my goodness, I'm so sorry. I'm going to try to speak above what they're saying. But use that to convert the numbers. Okay. Yeah, they were doing some drilling yesterday too. Okay. Our next conversion here is about using density as a conversion factor. So let me talk about a general rule. The general rule is this: in chemistry, any number that has a unit over another unit can be used as a conversion factor. Chemists are notorious for that. They see a number and it's like, how can we use this number for our purposes? Okay. So now we're going to be using density as a conversion factor for our purposes. So we're told here the mass of the fuel in a jet must be calculated before each flight to ensure that the jet is not too heavy to fly. This kind of gives me some concerns, right? I didn't think about the fuel and how much fuel they have to use, but I guess you want to make sure you have enough fuel, but not too much fuel. A 747 is fueled with 173,231 liters. So, okay, they have the given right here. So I'm not going to rewrite it, but you guys make sure you write it down. By the way, when you're listening to me, go ahead and write down stuff because I write certain things that are not necessarily part of the original PowerPoint. That way you have access to it, and then you're being actively engaged, right? So we got 173,231 liters. So we're right here. If the density of the fuel is 0.768 grams per centimeter cubed, what is the mass of fuel in kilograms? So what is wanted is kilogram of fuel. Fuel, if I can spell fuel, okay? Let's do examination of significant figures before we start our math. This is 1, 2, 3, 4, 5, 6. I have 6 significant figures here. I have 3 sig figs here, and I think I'm good to go. Of the 2, the 3 sig figs wins, right, for our answer. So our answer will have to be rounded up or down to 3 sig figs. Let's go ahead. I'm going to open up a new page here. I'll add a page because I like my space. So I have 173,231 liters, and I'm given the density of fuel as 0.768 gram per centimeter. So here's the thing, because at first, as I told you guys probably many times, that when I was taking chemistry, started off in middle school, I'm looking at a teacher and I'm totally clueless. I'm just like, they seem to know what they're doing, so I'm just gonna follow along blindly. I have no idea why we're doing this, but oh well, let's see if it works out. And it was more like a Russian roulette thing, right? After a while, I realized, hey, they're notorious. Every time there's a number that has a unit over a unit, as a conversion factor. Knowing that, I like to write my fractions like fractions, okay? 768 grams over 1 centimeter cube. It's like I feel like there's there's no winning with this thing. I apologize once again for the noise. So 0.768 grams over 1 centimeter cube, because I'm going to be using it as a conversion factor. Okay, now I want to highlight the similar units, right? Similar as in the same kind of measurements. I have a liter here. I have a centimeter cube here. These are both volumes. Here's the issue. They're not the same unit. So since they're not the same unit, I have to reconcile the units. I have to get a conversion factor that has both the units in one conversion factor. So this is where that little chart comes in handy. You see why I have to have 3 pages open at all times? There. So liter is in the volume section. So I go to liter. I'm looking for liter and centimeter cube. Oops, right there. 1,000 centimeter cubed equal 1 liter. So I go with write the number. 1,000 centimeter cubed equal 1 liter. Yeah, 1,000 centimeter cube equal 1 liter. Okay, so now we're back here. Are you guys able to hear the drilling sound? Because I think I need to go talk to them, which is hard to do right now, and tell them that I do have a class in the morning. Can you guys hear the drilling sound, or is it just me? Hello? Are you guys able to hear the drilling sound? Okay, it's just a little bit in the background. Okay, thank you. I feel bad because I'm like, I'm doing this lesson right now and y'all are here right now, and it's okay. As long as it's not so loud for you, it is super loud for me, but yeah, I'll power through. Okay, thank you. So yeah, so I got the conversion I needed, right? Uh, there is one more conversion I will need, but because they said I have to go to kilograms, right? So let me pull this up again. I need one more conversion. I need to go from grams to kilograms. So I'm seeing, oh, right here, first one in the mass. 1 kilogram is 1,000 grams. So 1 kilogram is equal to 1,000 grams right there. Okay. So that will be our conversion. Okay. Our two conversions. So let me start once again. Now we have 4 numbers to work with. And with these 4 numbers, the question is, which one do we start with? Okay. Start with the number of the simplest unit. So start with number with simplest units. Okay. So you have all these numbers. Pick the one that has the simplest unit. So that will be this one here. Okay. 173,231 liters. Start with that. I'm already seeing them writing too big, so I'll write a little bit smaller. I just use that. Now I have to bring in a conversion that has liters in it. Okay, so this conversion right here, that has liters. So the 1 liter can go on the bottom, the 1,000 centimeter cubed can go on the top. Done with the next one. Okay, liters and liters cancels out. What drives my next move? Centimeter cube. So I look around, find the numbers I have in front of me with centimeter cube. Is this one's turn right here. Once again, you're using the numbers as a combo, right? So centimeter cube has to be on the bottom. So 1 centimeter cube goes here. Then 0.768 grams go on the top. Done with this one here. Centimeter cube, cancel out. Now my next move is driven by grams. Find the unit that has the grams, or the conversion that has the grams. That will be this one here. So I have to use 1,000 grams on the bottom, and then 1 kilogram on top, and bam, I got my answer. Well, not really my answer, but I got my problem set up. I got grams and grams. Oh, people, I hope y'all are still alive up there. Okay, so now we do the math. We'll get our answer in the correct desired unit, right? 173,231 times 1,000 times 0.768 times 1. Okay, so I'm writing here 173,231 times 1,000 times 0.768 divided by 1,000, right? Divided by 1,000. Okay, so my answer, my long answer is 133,041.408 kilograms. Okay, since I was given two numbers with this one being in three significant figures, this rules my answer. So position-wise, this stays, this stays, this stays. Everything else has to be dropped off, right? So this number will be 133,000 kilograms. Or you can write it as scientific notation if that's more comfortable for you. You can write it as 1.33. Hold on. Okay. Move the decimal, right? 1, 2, 3, 4, 5 times 10 power of 5 kilogram. So you can write it like the top number, like this, or like the bottom number, whichever is easier. Okay. Any questions about this? So you saw how I use the density as a conversion factor, right? That's why chemists prefer dimension analysis over the formula. The formula is so limiting on what you can do with it. Dimension analysis is almost allows people to go rogue with the math, right? But chemists love that. They love being able to use the math to get what they want because that's their motivation. It does kind of upset math people, but yeah. And so here is the end of chapter E. Does anybody have any questions about chapter E, homework, quiz, whatever? Any questions before I move on to the next chapter? Were you all able to work on the lab? The first lab, the graphing lab? I did a session, a tutorial session. Alifia, you have the conversion table with you whenever. So it's since you asked, yes. Let me show you where it is. So right here, where is it? Is this one here? Oh, sorry. The conversion table was available for the second one, right? So right here, if you click on the PowerPoint, because I use it with the PowerPoint, it's right here. So it's available to you right now. And yes, you can use it for the exam. Okay. I put it in the second, in chapter 1, just because we used it more over there, but it's available right here. So for the attachments I give you guys, yeah, you can use them. Your exams are literally open books. So whatever resource you want to use, go ahead and use it. I would rather the book so you're learning the technique versus just Googling your answers. Because if you're in Gen Chem, you're going to be held accountable at some point for this stuff, right? So hopefully that answers your question. Oh, okay. If you're having trouble opening up, send me an email. I can send you the PDF. I have to keep them zipped up because of the accessibility stuff I have to follow, or else I get emails saying you need to do this stuff. So if you cannot download it, please send me an email saying, can you please send me the PDF format for it? It is in the PDF mode. So if your calculator, if your computer cannot open PDF, that will be an issue either way. Okay. Yeah. So it's PDF. So yeah. Other than that, yeah, just send me an email and then I'll go ahead and send this to you. Because for the most part, right now, For the PowerPoint, I have this on an app. It's not really projecting directly from Blackboard, but I'm trying to think. Yeah, I can't convert that because I found this online in this format, and I go by that. Yeah. I feel like I tried to convert it one time to the Word format, and it just jumbled everything. So you don't have to use this. I'm just so used to using this. They have many other conversion tables. You can just Google online, find conversion tables. They have many. I like this one because it's so simple. It's so old school and not really, over the top. And you have all these over here. Okay. Okay. So let me see. Uh, oh, chapter one. I think I'll write a note to myself to move the conversion or to even put an extra copy of conversion table. I have to write myself notes in the future because if I don't, I forget. So to do, add conversion table to chapter one. Chapter E, sorry. Chapter E, because we do use it in the end of chapter E. Okay. Oh, I forgot. I forgot. I have to stop the recording so that I can post it as, yeah, so this makes no difference to you. So let me just stop.